Hello students. Now we have completed chapter number 1. Now we are going to start chapter number 2, Polynomial. As we learned in standard 9 and standard 8, first thing we should know that what is polynomial. Then an equation which have one and only one variable. That means if we have any equation, if in that equation we have one variable, then it is called as a polynomial. But instead of one, if you have more than one variable, like 2x square plus y equals to 7, this equation is given. So here, how many variables are there? So here we have x and y, two variables. So this one is not a polynomial. Understood? If you have 3x square minus 5x plus 1 equals to 0, then how many variables are there? X, only x. No other variable is there. So it is polynomial. Understood? So in equation, if you have one and only one variable, then it is called as a polynomial. But if you have more than one variable, then it is not a polynomial. Understood now? Now, here we have variable as x. Now polynomial is denoted by p of x, where x is variable. Some of the times, if I say y square plus 7y minus 5 equals to 0, this equation is given. This is polynomial, yes or no? So yes. Why? Only one variable. But here now we have variable as y, not as x. Understood? Degree of polynomial. This also we learn in standard 9. What is degree? If you have a polynomial, first thing, and after having polynomial, highest power of variable is called as degree of polynomial. Understood? 2x minus 7 equals to 0. First thing, is it polynomial? Yes, because only x is variable. Now what is the highest power of x? X with power 1. Any other x term? No. So degree is 1. If I say 7x raised to 4 minus 5x raised to 5 plus 3x equals to 9. Is it polynomial? Again yes, because only x is variable here. Then what is degree? Maximum power. X with power 4, x with power 5, x with power 1. So maximum power is 5. So degree is 5 only. Understood? By the degree, we have some types of polynomial. First one, linear polynomial. What is linear polynomial? In this type of polynomial, degree of polynomial is 1. When degree of polynomial is 1, at that time polynomial is linear. Like this equation. This one is polynomial because one variable, and x with power 1. So it is linear polynomial. Same thing, 5x equals to minus 2. So again x with maximum power 1. So it is linear polynomial. But I say 7x square minus 3x equals to 2. It is not a linear because x with maximum power 2. Clear? Now, quadratic polynomial. When polynomial have degree as 2, means maximum power of variable is 2, then that polynomial is quadratic polynomial. Like x square plus 3x plus 2. What is the maximum power of x? 2. So it is quadratic type. Okay, 2x square minus 7x. Maximum power of variable 2. So it is quadratic type. 5x square plus 4. Again maximum power is 2. So it is quadratic type. Understood everyone? And cubic polynomial, polynomial which have degree 3. Okay, if you have degree of polynomial is 1, then it is linear. Degree of polynomial is 2, then it is quadratic. And degree of polynomial is 3, then it is cubic type. Like x cube plus 2x square plus 7x minus 4. Here maximum power is 3, so it is cubic type. 4x cube minus 7x plus 4. X with maximum power 3, so it is cubic type. 3x cube plus 12x square minus 1. X with maximum power 3, so it is cubic type. Understood? This one are the types of polynomial by the degrees of polynomial. Clear? Understood everyone? Now, zeros of polynomial. Zeros also can be called as roots. Zeros or roots of polynomial. Now, what is zeros? Values of variable for which value of whole polynomial becomes 0 are the zeros of polynomial. That means in this type of polynomial, for which value of variable whole equation becomes 0, that value is zeros or roots of polynomial. Now, we have a question. Check whether these four, 2, minus 2, 1 and minus 1 are the zeros of p of x equals to x square plus x minus 2. We need to check these all are the zeros or not. Then what you should do? Put these values inside the polynomial. If you get value of whole equation, whole polynomial is 0, then it is zeros. As we see in definition, value of variable. These are the values of variable. For which value whole polynomial becomes 0. If you put 2 here and equation answer you get as 0, then it is zeros. But answer is not 0, then it is not zeros of equation. Understood? So what you should do first? Instead of variable, put this value inside equation. Now, take x equals to 2. So, p of 2 equals to. Now, p of x we have is x square plus x minus 2. But now we want p of 2. So, in this equation, wherever you see x, you should write 2. So, square of 2, 2 minus 2. Square of 4 plus 2 minus 2 cancel. Clear? Now, 4 equals to 0? No, 4 is not 0. So, x equals to 2 is not zeros of p of x. Understood everyone? First we take x equals to 2, then we took x equals to 2 in whole polynomial. We found the value which is 4, which is not 0. So, value of the variable which is 2 is not the zeros of this polynomial. Now, take x equals to minus 2. Now, p of minus 2 equals to minus 2 square plus minus 2 minus 2. Square of minus 2, 4 plus minus minus 2 minus 2. 4 minus 2, 2. 2 minus 2, 0. Now you get 0. Understood? So, minus 2 is, so x equals to minus 2 is zeros of p of x. Understood? Now take x equals to 1. So, p of 1 equals to square of 1 plus 1 minus 2. Square of 1. 1, 1 plus 1, 2, 2 minus 2, 0. Clear? So, x equals to 1 is zeros of p of x. Understood? At last, put x equals to minus 1. Now, p of minus 1. So, minus 1 square plus minus 1 minus 2. Square of minus 1. Plus minus, minus 1, minus 2. 1 minus 1, 0. 0 minus 2, minus 2. Is it 0? No. Is not equals to 0. So, x equals to minus 1 is not zeros of p of x. So, at last we can say x equals to 2 and minus 1 are not zeros of p of x, and minus 2 and 1 are zeros of p of x. Understood everyone? Clear? What we do? Put this value inside polynomial for which whole value becomes 0. Those values are zeros. For those whole value is not 0, those are not zeros. So these two are zeros of polynomial and these two are not zeros of polynomial. Clear everyone? Now, if you want graphical representation of polynomial and variable, so first we know that this one is coordinate geometry. This one is x-axis, this one is y-axis. On x-axis, value of variable. On x-axis, let me take value of variable. Same for this graph. On x-axis, value of variable. Clear? Now on y-axis, that we are taking value of polynomial. On y-axis, let we are taking value of polynomial. Same thing here. Now on y-axis, let we take value of polynomial. Now, first, what you should do, just assume some value of x and put that value in equation. Let x equals to 0. Then p of 0 for this one means for this polynomial. If you take x equals to 0, then p of 0, which is 3 into 0, 0, 0 minus 6, minus 6. Let x equals to 1. Then p of 1 equals to 3 ones are 3 minus 6, minus 3. Let x equals to 2. Then p of 2 equals to 3 2s are 6, 6 minus 6. And x equals to 3. Then p of 3 equals to 3 3s are 9, 9 minus 6. Now, let x equals to minus 1. Again in this equation, for this polynomial only. If you take x equals to minus 1, then p of minus 1 equals to minus 3 minus 6, minus 9. And if you take x equals to minus 2, and we are not taking negative values right now. So if you take x equals to 0, value of whole polynomial becomes minus 6. If you take x equals to 1, then value of whole polynomial becomes minus 3. If you take x equals to 2, then value of whole polynomial becomes 0, and x equals to 3, then value of whole polynomial becomes 3. Now let me answer that. 1, 2, 3, 4, 5, 0, minus 1. We are not answering minus values. We are not taking my negative sign values. So minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. This side 1, 2, 3, 4. Now, when we take x equals to 0, this one is value of variable. So value of variable we are considering on my x-axis. When x equals to 0, then p of 0 equals to minus 6. So when x value is 0, y value is minus 6. So y value, which is polynomial value, minus 6. So So when x 0, y minus x, what point is here? Clear? When x is 1, y value is minus 3, means polynomial value. X is 1 and p of 1 is minus 3 here. So common point is here. When x is 2, whole value becomes 0. When x is 2 here and polynomial value is 0. So this point only, as we learn in standard 9, just plotting the points. When x equals to 3, so here polynomial value is 3 here. So that intersection point is nearly here. So passing from there, we have one line. Clear? Now this line represents this equation, 3x minus 6 equals to 3 of x. Yes, this line represents this polynomial. Now look here. In this graph, which shows this equation, this line. Now, at how many points this line intersects x-axis? So only at this point. So by the graph, we can say how many zeros this line has. Only one zeros. This line means this polynomial has, and value of that zeros is 2. Understood? So x equals to 2 is only a zeros of this polynomial. Understood everyone? So by seeing the graph, we can directly say how many zeros are there. Clear? Now, p of x equals to x square minus 4. And same thing we are doing. We are forming a graph. Let's say x equals to 0 and p of 0 equals to 0 minus 4 minus 4. Let x equals to 1 and p of 1 equals to 1 minus 4 minus 3. X equals to 2. Then p of 2 equals to square of 2, 4. 4 minus 4, 0. When x equals to 3, p of 3 equals to square of 3, 9. 9 minus 4, 5. When x equals to minus 1, and p of minus 1 equals to, what we are getting? P of minus 1. Minus 1 square, square of negative number. We will positive. So minus 1 square plus 1, 1 minus 4, minus 3. If you take x equals to minus 2, then square of minus 2, 4. 4 minus 4, 0. So p of minus 2 equals to 0 and x equals to minus 3. Then square of minus 3, 9. 9 minus 4, 5. Now let's form 0, 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Minus 1, minus 2, minus 3, minus 4. Clear? And 1, 2, 3, 4, 5. Now, when x equals to 0, polynomial equals to minus 4. X equals to 0 means here, and equation is minus 1, so here, this point. When x equals to 1, p of 1 is minus 3. When x equals to 1 means here, and minus 3 here. So our point is here. Now, x equals to 2, then p of 2. X equals to 2, then p of 2 0. So here, this point only. When x equals to 3, then p of 3 5. X equals to 3, then p of 3 5. So here, clear? Now x equals to minus 1, then p of minus 1 equals to minus 3. X equals to minus 1, which is here, and p of minus 3, which is here. So nearly this point. Clear? Now x equals to minus 2, which is here, and p of minus 2 is 0. X equals to minus 2 and p of minus 0, so here, so this point only. And x equals to minus 3 here, and p of minus 3 5. So here this and this. Now join them points. Which is parabola. Understood? So by seeing this figure, what you can say? At these 2 points, value of polynomial is 0. At these 2 points, value of polynomial is 0. So number of zeros 2, 1 and 2. And which are the zeros? Minus 2 and 2. Understood? So by seeing the graph, directly we can say how many zeros this equation have. Clear? Let me ask, if you have a graph like this is the value of zeros, this for the value of polynomial. Now, at how many points this graph of polynomial touches the x-axis? At 1 point, this one. At 2 point, this one. 3 point this one. So there are 3 zeros for polynomial. Easily you can say by seeing the graph. Understood everyone? Now you need to solve whole exercise 2.1 by yourself. There are some questions of graph. By seeing graph you need to say how many zeros are there. Clear everyone?